Hello and welcome to the Chandara Academy. In today's video, we are going to find the limits of different expressions. So we are in the part 2 of the video. In the part 1, we solved expressions A, B, and C. In this video, we will solve expression D, E, and F. Let's start with D. So the expression D of x is equal to exponential of minus x minus 1 over sinus of 2x. How do we do this kind of limits? Because we are interested in the limits when x tends to 0. We will have something which has the form minus 1, so 0 over sinus of 0, 0, which is a non-defined limit. What do we need to spot here is that we've got sinus of something that tends to 0, and we know the limit x over sinus of x when x tends to 0 is equal to 1. So we just have to arrange a little bit of an expression to make a 2x appear here, and we have something like exponential of minus x minus 1. So how do we do that? We just have to see that this is minus exponential. So this is exponential of minus 0 plus x minus exponential of 0. And we will have an x that will appear, okay, because we will make appear a 2x at the top, so at the bottom 1x will appear. And this is approximately the derivative of exponential of x. So we will see how we do it precisely in the exercise, but this is what you have to think about when you see those kind of exercises. So what do we want to do first is to make appear a 2x at the top. So what do? We multiply by 2x and we divide by 2x. So why can we divide by 2x? Because we've got x different from 0. We want x that tends to 0, not x that is equal to 0. So times 1 over sinus of 2x times exponential of minus x minus 1, okay, which is equal to 2x over sinus of 2x times 1/2 times exponential of minus x minus 1 over x. We do know that this thing will tend to 1 when x tends to 0, but what about this thing? So we want to have something that is exponential of x prime, so in x it's equal to 1 value, so here x is equal to 0, and this thing is exponential of x minus exponential of 0 over x. So we want the limit when x tends to 0 of something like that. You see, to have something like that, we have to make a little change of variables where we put x is equal to minus x, because we want to have a x in this in the exponential. So let's do it. We will have 2x over sinus of 2x times 1/2 times exponential of x minus 1 over, so this x turns into a minus x, okay, minus capital X times minus capital X, okay. And so by product we will have the limit of d of x when x tends to 0, which is equal to the product of the limit when x tends to 0 of 2x over sinus of 2x times, so here is a minus 1/2, which is a constant we do not care about her, times the limit, so I will write it down here, so times the limit when x tends to 0 of exponential of x minus 1 over x. So why is it when x tends to 0? Because you see that x is equal to minus x. So when minus x tends to 0, okay, it implies capital X tends to 0 as well. So when x, little x tends to 0 means capital X tends to 0. And what do we have here? So for the first one, we will have is equal to 1. Okay, we said it because this is x over sinus of x when x tends to 0 times minus 1/2, this constant, times exponential of x prime in 0, okay, with x is equal to 0, which is equal to 1 times minus 1/2. Exponential of x prime is equal to exponential of x evaluated in x is equal 0, which is equal to 1 times minus 1/2 times exponential of 0, 1, is equal minus 1/2. So we have d is equal minus 1/2. So you have to remember about this technique, because I will go a little bit faster for other limits. So limit e of x, so the expression within our limit, is equal to x plus 1, so the x plus 1 over x plus 3 to the 2x power, okay? And we want the limit in plus the infinity of e of x is equal to what? So in plus the infinity, we will have this thing that tends to 1 and this thing that tends to the infinity. And 1 power infinity is undefined as well. So first, when you have things with exponents like that, what you want to do is to use the logarithm rules. So it's equal, let's remember that x is equal to exponential of ln of x. And when you know it, you can say that e of x is equal to exponential of logarithm of x plus 1 over x plus 3 to the 2x power. Also, we've got logarithm of a to the b power is equal to b logarithm of a. And so we can put the 2x outside of the ln is equal to exponential of 2x times logarithm of x plus 1 over x plus 3, which is the same thing. So I would rather have the x plus 1 down the fraction is equal to exponential of minus 2x. And when I put a minus here, I can switch the two sides of the fraction. Logarithm of x plus 3 over x plus 1. And what do we want to have now? So we know that the limit of logarithm of 1 plus x over x when x tends to 0 is equal to 1, okay? Because this is equal to ln of x prime evaluated in x is equal 0, because this is the definition of the derivative, okay? This is an identity you need to have in your head. So we want to find this identity here. How do we do? So we want to have something like 1 plus x in the fraction, okay? So exponential of minus 2x logarithm of x plus 1 over x plus 1 plus 2 over x plus 1. This thing here is equal to 1. So we do have something like logarithm of 1 plus something that will tend to 0, because when x tends to plus the infinity, we have 2x, we have 2 over x plus 1, which tends to 0. So this will be our capital X, okay? So let's say it. We want capital X to be equal to 2 over x plus 1. So we are going to solve for x. So we got x plus 1 times x is equal to 2. So x is equal to 2 over capital X minus 1. And when we have this, so we want to have capital X everywhere in this expression, so we just replace. You got exponential of minus 2 over 2x minus 1 times logarithm of 1 plus x, which is equal to exponential of minus 2. So I will develop minus 2 times minus 1, so plus 2 times ln of 1 plus capital X. So this was this development here, here, and here, and minus 4 times, so minus 4 times logarithm of 1 plus x over x. And we now just have to take the limit. So the limit when capital X tends to 0, because this is the same limit as when x tends to plus the infinity, because when x tends to plus the infinity, so x tends to plus the infinity implies capital X tends to 0, because 2 over plus the infinity is equal to 0. So this limit, so the limit we are looking for, is equal to the limit when x tends to 0. This is called a change of variables. Is equal to exponential of 2 plus 2 times ln of 1. So 2 times ln of 1, which is 0, minus 4 times, and we said that this limit is equal to 1, 4 times 1. So why can we put the limit inside of the exponential? And this is really important, because exponential is continuous. So we can say that limit of exponential of f of x is equal to exponential of limit of f of x. Okay, because exponential is continuous. So this is our case. And so the limit f is equal to exponential of ln of 1, so 0. So exponential of 0 minus 4, which is equal to exponential of minus 4. And in conclusion, f is equal to 1 over exponential to the 4th power. Then let's go for the last limit. So we will have limit of ln of x minus 1 over x minus e. And this feels a lot like a derivative again. Let's let's write down the limit. So we will have g, which is equal to the limit of j of x when x tends to e, which is equal to limit when x tends to e of ln of x minus 1 over x minus e. And what do we have to see here is that this thing will tend to 0 when x tends to e, and this is not luck, because here what is 1, we have to spot it because this is the only way to solve the thing, okay? In grade 12 you have some methods that are always the same. So when we have an exercise, we know that we can solve it easily. So we are looking into our little toolbox with methods, and this thing looks like a derivative. So let's go and look for a derivative. And what is the one? The one is ln of e. Okay? So let's write down g of x as ln of e, ln of x minus ln of e over x minus e. Okay, so now we want to have something clear, a clear derivative. So let's do a change of variables and put this thing here as capital X. Okay, because we want to divide by something that tends to 0 clearly. So if capital X is equal to x minus e, that means that little x is equal to x plus e. And so now g is equal to the limit when x tends to what? So when little x tends to e, we have capital X that tends to 0. So capital X that tends to 0 of logarithm of x plus e minus logarithm of e over x. And this is exactly the derivative of ln of x. So ln of x prime evaluated in x is equal to e. Okay, this is exactly the definition of the derivative. Okay, so j is equal to ln prime of e. If you will, what is ln of x prime? This is equal to 1 over x evaluated in x is equal e. This is equal to 1 over e. So we got g, which is equal to 1 over e. And we solved the video. So always, in conclusion, look for, into exercises, look for something you know. Because exercises are made for you to solve them. So hope you enjoyed the video. See you soon. Bye.